Let's look at this sample AP question. It says answer the following questions about the solubility of some salts with the metal cation X2 plus. So this is like an unknown alkaline earth metal. And it says we put this into, we have 0.2 grams of the solid and we put it into 100 milliliters of distilled water. And then it says that our OH is this concentration. So first of all, write the chemical equation for the dissolving of this solid. So I do know that the X is a 2 plus because they told me. And then I can also figure it out by the hydroxide ion. So the hydroxide ion is a -2, and I have to have 2 of them, so therefore the X must be a +2. And don't forget this little 2 in front of the OH. It is a 1:2 ratio when it splits up. Now it says calculate the number of moles that dissolved. So that's important. So we're not going to use this 0.2 because the only thing that we know is how much OH dissolved. So that's what I'm going to start with. So instead of molarity, I'm going to change that to moles per liter. And then I'm going to multiply it by how many liters I have. And I have 100 milliliters, which is 0.1 liters. And multiplying this out, this is how many moles of my OH dissolved. Now it wants moles of the solid, so I need to do some stoichiometry. So I have that many moles of my OH, and I know for every 2 moles of my OH, I have 1 mole of my solid. And that's what they want. They want the moles of the solid. And so I'm just essentially cutting this number in half. So that is how many moles of my solid that's dissolved. Now the third thing it wants us to do is determine the value of the solubility product constant Ksp for this solid at 25 degrees Celsius. And this temperature just lets us know that we're going to just find the Ksp at that temperature. We're not really going to use the temperature in the problem. Write your formula, Ksp, and now let's put in the values. So I know what my OH is. My OH is given to me 1.17 to the -5th, and don't forget to square it. And now let's look at our X, 2 plus. So when I look at the ratio, this is a 1:2 ratio, or if the OH is a 2X, then my X 2 plus is going to be an X. So what I'm saying is if I know that this number, which I do, I'm going to divide it in half to find what the X is. So I'm just going to put a little divided in half this number. And when I solve this, I get 8 times 10 to the -16. So that is my Ksp value. They gave us the OH value, but remember that's double that X to the 2 plus value. Okay, let's continue on. So it says a beaker contains 500 milliliters of a solution, and there's sulfate ion and carbonate ion in there, and it gives their concentrations. And it says a student intends to separate the ions by adding 0.2 molar of the X to the NO3, so a nitrate of that metal, and add it 1 drop at a time from the burette. And that does give us the Ksp value of both of the precipitations that may form. And it says which salt will precipitate first, the carbonate or the sulfate, and justify your answer. So that means I need to give the answer and then tell why. And looking at those Ksps, I find that this is my smallest one, and your smallest Ksp will always precipitate out first. So when you're doing drop by drop, this is the one that's going to precipitate out first. So I'm going to say the sulfate one, because of it's the lowest Ksp. Then it says calculate the minimum concentration necessary to initiate the precipitation of this salt. So I know what the Ksp is. It's given to me. It's this 6 times 10 to the -19. And that's going to be equal to the concentration of my X, 2 plus, and then that sulfate ion. Now I do know the concentration of the sulfate ion, and it is given to me up in the text. It's a 0.1. So I'm just going to go ahead and stick that in. I didn't give myself a lot of room to show you this, but this is 0.1 is what the sulfate is. And so I can go ahead and just put that there and then solve for the other ion. That is going to give me that minimum concentration. So I'm going to have 6 times 10 to the minus 19 divided by 0.1, and I'm going to get 6 times 10 to the minus 18. So this is the minimum concentration to precipitate this out. So not a lot, so a portion of a drop would do this. And then let's do the last part. It says there are several ways to dissolve salts that have limited solubility. Describe one procedure to redissolve the precipitate formed that we just formed. And there's a couple different ways you could do this. You could add more water. So that would lower the total concentration of those ions, and so to get them to dissolve back. And the other thing too is you could add heat. With solids, by adding heat, you can dissolve more. We're going to talk about pH in our acids and base unit, but I do want to just address it briefly right here and talk about pH and solubility. Some substances dissolve in an acid or a basic solution better, and it's a combination of the common ion effect and Le Chatelier's principle. First of all, just a little brief introduction to pH. So anytime you see a hydrogen ion, that is the acid particle. That's what makes it acid. And a hydroxide ion, or OH minus, that is a base. And your pH scale runs from a 0 to a 14. If you have a pH number less than 7, that is acidic. If it's 7, that is neutral, right in the middle. And if it's bigger than 7, that's basic. And this is something that we will address in our acids and bases unit, but when you have hydrogen ion reacts with an OH ion, this is a neutralization reaction. It makes water, and here is the reaction. So if you were to add an acid to a base, you're just making water. And here is a sample equation to show you how pH will affect the solubility. So let's look at this. We have magnesium hydroxide solid, and it's in equilibrium. So there'll be a little bit of solid at the bottom. It'll be at equilibrium. And then let's look at the difference if we add it to a basic solution and if we add it to an acid solution. So if we add it to a basic solution, that essentially is adding hydroxide. And so that is going to cause the reaction to shift this way. So I'm actually going to dissolve less if this happens. Now let's look and see what happens if we add it to an acid solution. So if we add it to an acid solution, this OH right here is going to be removed. And so I'm going to remember take toward, it's going to shift this way. How it's going to be removed is the acid will bind up that OH, essentially removing it and making water, which remember water doesn't affect equilibrium because it's a liquid. This is going to shift it to the right hand side, and you're going to be able to dissolve more.